What's the time?
Set your own down, not put down. There is no way you understand it without having it. Get your own down.
Let me just do the performance look for dynamics. Alright, dynamics is the study of motion. Respect the force causing it. Dynamics is the study of motion with respect to the force causing it. Dynamics is the study of motion with respect to the force causing it. I don't understand why each time I come here and go behind the next thing is always happening. Check out how many there's any share and high today. Just like for our work, don't come and catch me and go. So I said, the next is the story of motion with respect to the first person. Have you written it? The next is the story of motion with respect to the first person. It can also be defined as the story of force. The dynamics is the study of motion with respect to the force causing it. Full stop. Dynamics is the study of motion with respect to the force causing it. It can also be defined as the study of force. It can also be defined as the study of force causing motion. It can also be defined as the study of force causing motion. Full stop. Are you getting that? Yes. Alright. Now we can classify dynamics into three categories. We can classify dynamics into three categories. Number one is horizontal dynamics. Horizontal dynamics. Or you say dynamics on x-axis. Dynamics on x-axis. Number two is vertical dynamics. Or you say dynamics on y-axis. On y-axis. Then number three is plane dynamics, or you say inclined plane dynamics. Inclined plane dynamics. Or you call it dynamics on z-axis. Dynamics on z-axis. Full stop. So please, we'll get all the formulas today so that by tomorrow we'll start calculation. Saturday, we'll do our practice. So these are the categories of dynamics that we have. Have you written it? Yeah? Okay, sorry. You can see it now. So dynamics on x-axis, vertical dynamics, y-axis, inclined plane dynamics on z-axis. Good stuff. So please, we need to know that another name or another way to remember dynamics is simply that dynamics talks about the laws of motion, while kinematics or kinematics talks about the equations of motion. So dynamics talks about the laws of motion. So you can just say simply put, dynamics talks about the laws of motion. Simply put, dynamics talks about the laws of motion. Good stuff. So under dynamics, we have what we call the Newton's laws of motion. Under dynamics, we have what we call the Newton's laws of motion. What we are writing. So the first law is what we call the law of inertia. Yes. Those in the next step, they still go on to further this. So law of inertia.
Okay, you know me now. This is physics fast paced. Get it so that you understand everything here. Little by little. Yes.
Alright, so I said law of inertia. Notice that if I carry this phone, like I said the last time, and keep here and leave, what will happen? Will you leave? Yes, I will. Yes. So anytime you want to remember this Newton's first law, always remember that that law, they define that law when they have not brought out phone. So people have not started thinking about it. So the law says that the body at rest will remain at rest, and if in motion will continue moving until acted upon by external force. So that first law. The first law says that the body at rest will remain at rest, and if in motion will continue to move until acted upon by an external force. You are not right. This is my small friend. When you are right. Your name is not today. Come to our space. Come to our space. You know something. You know that. Henry. You have space. You know something. Everybody must know in this class. So, I said, the body at rest will remain at rest, and if emotion will continue moving, but it acted upon by external. Notice that if I hold this manner, you notice that if it moves and nothing hits it, at a point it will fall down, actually. The transfer particle distance it will fall down. So what Newton is saying is that there is a force acting on it, there is an invisible force, and he gave that invisible force to friction. And then he said that if the body is thrown vertically, that is all. That if you get to a particular point, it's normally supposed to continue going, but there's a force that we want it to come down, which is called what? So I normally tell my students that the short form or the simple thing to get from this first law is simply that friction is to the horizontal. Friction is to the horizontal force what gravity is to the vertical force or vertical motion. Are you getting it? Yes. So we move to the second law. Why am I putting all these things for you to do? Because as we start solving calculations and as we start deriving formulas, we get a lot of formulas from what we have here. So the second law states that the force applied to a body is directly proportional. And you know that anytime they tell you rates, it means that particular thing divided by time. Are you aware? Yeah. Okay. So if I tell you that, for example, acceleration is the rate of velocity, it means velocity divided by time. Okay. So this law says that the force applied to the body is directly proportional to the rate of change of its momentum. Is directly proportional to the rate of change of its momentum. The force applied to the body is directly proportional to the rate of change of its momentum. And when you make this to have a quality sign, you know that there will be a proportionality constant which is k, should be? And this k is always equals to 1 actually. And 1 times anything is that thing. It is from this same equation you get if you cross multiply, you come and get something like f equals to f, should be? It's from this equation you get what we call impulse. Because impulse is the product of force and time. Which means that impulse is the same thing as saying it is equals to momentum. I feel that anytime you say something is equals to something, even if it's m here, it means that when I solve this thing, you should give me this. Yeah. So which means if I am given just impulse and I have mass and velocity there, I can use impulse to be mv. And this thing means that if I'm given v, it's the same thing as saying that I have mv minus mv. Do you understand this? Do you understand? This mv is the same thing as saying mv minus mv, or the same thing as saying m into v minus v. Should we agree? Yes. Whichever way. Because when I have just v, it means that they've already done the math before giving me this. But situation where I don't have those, I will now remember that if I have initial velocity, I can subtract. It is also from this same equation. Notice something here. Velocity over time is what? Which means that everything here can stand for A. Is it not true? So that I now have that F is equal to what? And I hope you know that what this equation of what is talking about is that if I move the body like this, it will go like this. If I move it like this, it will go like this. Maybe you know. So it's telling me that any direction I apply force, that's the direction the body will go. So that's the second law. So those all the formulas will be right here because when we get to linear momentum, conservation of kinetic energy, velocity, collision, elasticity, we'll still be dealing with this. So let's move to the third one. The third and the last one. The third and the last one. So that we can now compare these laws to all the formulas we derived for when the body is in horizontal motion. The dynamics there. When it's a capital, what is there? When it's on a decline, what is there? Then we go to start solving the calculation aspects. So the third law and the last law. Do you know that if a small boy come and slap you, like that my small friend, hey, if he slap you, you will not feel it, you mean? Is it not true? Well, have you imagined a bricklayer or iron bender? Come and give you a slap, what will happen? You will feel it, you mean? Your head will shake, or you carry this to your leg now. If you eat this small, you will feel it pass, but there's no hit leg here. I might not come for class for like let's say 2 months. I am. So what that thing is simply telling me is that the level of impact you give, that you will receive the reaction. I see it. Yes. That is why even the white people will tell you that the difference between a white man and African is that the African man easily gets provoked. Yes. Why the white man will try to mend your logical reasoning, no problem. Yes. So there's a minute you apply the logical reasoning, you get the opposite of what you're expecting. Yes. So it's still that interesting. So that law states that to every action there's equal and opposite reaction. And please, I want to explain what I was talking about. Like to every action there's equal and opposite reaction. If I know naturally that force is equal to mp, should it? Yes. This thing is simply what I'm talking about one body. So what it means is that all the first law and the second law is concerned with when I have just one body. But the minute I start to compare two bodies, notice that when I said hitting my leg is the body mass. The word is also a mass. Is it not true? So the minute I have two bodies, we are no longer dealing with just force. We are now dealing with what we call forward and backward force. Because you give the action forward, you get the reaction backward. And everything must be equal to the mass of the system and the acceleration of the system. So when you are comparing just the first body, so in the third law you are comparing two, but as you are looking at it, you are looking at the effect of the first body because it was hit by the second body. And when you are looking at the second body, you are comparing the effect of the second body because it was hit by the first body. So what it simply gives us is that the third law is that we have forward reaction or forward force minus backward force. Backward force is equal to MA. So this becomes the senior or the chief formula that we'll be using for everything dynamics. Majority of what we'll be doing under dynamics will set that this formula. So if, for example, I am told that there is frictional force acting on the body and there is force there, it simply means frictional force is opposite force. And it simply means I will have F minus the frictional force equals to MA. And this is what I'm looking at this. I see it. While if I'm looking for the frictional force only, I will just have F as equals to MA. So backward force will always be only equals to MA. But once you are thinking of what formula for the forward force, you'll be comparing the forward force minus the backward force equals to MA. Alright, let's try to look at it from this angle. So now that we know the third law, let's now compare all the laws we've given with the horizontal dynamics, the vertical dynamics, and the inclined plane dynamics so that we can go home. So from tomorrow we'll start our calculation. So even from the physics manual, we'll now be checking for questions on dynamics. I have given you a question is talking about dynamics. Once the question is dealing with movements, and as he's talking about motion, he's still telling you that there is force there. You know it's dynamics. But assuming a question is telling you about about motion and nothing about force is being mentioned. What type of? Kinetic sharing? You see it's different. But there can be a case where they are telling you the force, telling you motion, then they are asking you what is the work done. What topic is that? So it falls under work, energy, and power, which is the next course we'll be treating after this one. Yes. So if I have, for example, two bodies, let's say these two bodies, I have 1,000 here, and I have another body, let's say this one is 700, and you know this is kg, should be kg. This is like 700. Yeah. Now let's say I have another body this way. Let's say this is the system. Let's say I have another body this way. Let's say this one is like 60 kg. Now, okay, if I include this, I've started talking about vertical. Sorry, I've not entered vertical because I know you. Then let's start gradually. Yes. Before you know, you carry your profession and come. We are still on horizontal, shall we? Horizontal dynamics. Now, when we talk about horizontal dynamics, we are talking about the force causing motion on horizontal axis. Now, what I want to ask you is, if this is the first body, let's say M1, this is M2. Notice that in this principle, we are going to be using Newton's structure. Is it not? Because it's more than one body. Shall we? So if I want to find the force here, what formula would I use? And if I want to find the force here, what formula would I use? And if I want to find the force on the whole system, what formula would I use? Let's start with the first one. Notice that the first one, the force that we're acting on it is called tension here. Is it not true? And we know that force on a rope is called tension. Provided they did not mention friction, provided they did not say that friction is acting on this body, we have no business with friction. Can you hear me? Because everything naturally, friction affects everything. But it's not every time I mention it. Provided they do not mention friction, no business with friction. So notice that this T here, when this body tends to be moving forward, because there was the pull now. When this body tends to be moving forward, it will be dragging this one. But as it's dragging, the weight of this one will be causing impediment. It will be causing it not to move the way it's supposed to move. That is for this particular one. Is it not true? So that means that this tension is a backward force for this particular object. While as it's moving forward, this tension is a forward force for this particular object. I see it. So for this first body, the force there will simply be T equals to the mass of the body and its acceleration. While for the second body, and I will use M1. While for the second body, notice something. It is going to be encountering forward force, shall we? And this one will be dragging it back. So it will simply be F minus C, shall we? Equals to M2. Yes. Are you seeing it now? Yes. Now, if somebody asks you, what is the equation of the system? You see that this is the equation of the system. Do you know why? It is having C. Is it not true? C is equal to M1A. Is it not true? Which means that inside this equation, you have C for it. So whatever value T gives you is also found here. Are you seeing it? Yes. So by the time I make this order of formula, I'll have that F here will simply be equal to M2A plus T. Is it not true? Yes. So whenever it has to do with horizontal motion, okay, let me do the work. You need to know that for horizontal motion, provided friction is not mentioned, the formula is simply forward force minus backward force equals to mass times acceleration. But if friction is mentioned, as we can mention friction in this, notice that, for example, they tell you that there is friction of 2 Newton per kg. If you go to buy fuel, they tell you that 1 liter is 1,140. Then they tell you 1,140 per liter. Should we? And by the time you buy 10 liters, you now have 1,140 times 10. Is it not true? So let's say, for example, they tell you that they have 2 Newton per kg resistance. 2 Newton per kg. What it means is that if you go to this 1,000, when it's 1 kg, 2 Newton force is acting here. 2 kg up to 1,000. I see it? Yes, the resistance. So by the time I do 2 times 1,000, shall we? I will then get 2 2,000 as my resistance. I see it. Notice that when you buy that fuel in naira, no matter the amount of liter you are buying, you don't say 2 naira liter. Yes, you know do. So my resistance will just be 2 newton, which is my equation. Now, if I ask you, what would be the equation of this particular first mass? What would be the equation? I am telling you, teaching me. Equals 2,000. Equals 10. You understand this? Let me see. What's happening now? Check out how many times you need before coming. Come with your lunch box. See, you're not shaming for anybody here. If you're going to come with your lunch box, some people be saying I'm a big boy, I don't have to carry food. They don't do that to the university. Come with your lunch box. See, I know that this is resistance. And if it's resistance, normally this body is forward should be this way. So if this is resistance, it should be going this way. Is it not good? Yeah. Which means that I will remember the third law, which is forward minus backward, action minus reaction, equals to mass and acceleration. So it will have this T forward for this one, it's a forward force for this one, minus this resistance to backwardness, everything equals to mass and resistance. So if there's resistance here, this is what I will use. And any place, in most of the past questions, you always see resistance of this 1 Newton per kg. Assume it's the way you buy your fuel. You understand? 150 per liter. So when you have a lot of it, times it to whatever you do. Hope I'm not too fast. Okay, well, just let's do it. Mariana, see, what if I ask you, now that I have 2 Newton per kg for this first body, what will happen? And you see that this first body will be struggling. Are you aware? Because of the fact that it is having less weight or apparent weight. You know that what you call mass is apparent weight. It's having less apparent weight compared to this one. So it will be struggling. It will be struggling. Because as you are applying the force, it will be struggling because it will be feeling the impact of this block. So if I ask you now, what would be the equation of this system now for this particular block? Okay, 2 times 7 shall be, which is 1, 10, equals to M2. That means you've understood it. It's not hard. Dynamics is like the simplest topic in physics. You just cruise past it. The only hard topic or what if dynamics is preparing you for is work, energy, and power. That's when you now come and be seeing some issues. But for dynamics itself, you just cruise, slow and pass it. Yes, once you know these formulas, all these concepts, however they want to set it. Now, with what you now know, let's not apply that our little vertical something. Let's test if you are now understanding. Can I do this? I see. If we now have, let's say, this is 2 Newton per kg, you're still here. We are still at the horizontal, but we just want to test our knowledge. Let's say we now have another block this way. Let's say this one is like, let's say, 300, yes, you are here, kg. Now, let's say this is resting, and notice naturally, for the fact that this is this way, this forward force will no longer be for this. Are you aware? There will be a force pulling this thing down now, which is called what? Gravity, right? And we know that gravity is talking about weight. Is it not true? And that weight is equal to mg. Is it not true? Even if I don't say mg, I can remember that if I have g here, this is still the m. Is it not true? Let me call this an m3. Now I want you to now get me the force of this system. What will be the force of this system? With what we know now. That is, you know that the one that is forward will always be the force of the system because the rest are found inside it. Are you noticing it? Yes. So let's do it together. So I have the first one. C